Hello, how's it going, guys? Today we're going to do just a couple examples involving factoring out monomials from polynomials. And we do that by determining what the greatest common factor is. Okay, so what do we mean by greatest common factor? Well, that means that, it's the greatest thing that is contained in each and every term, right? And it sounds like you should be taking out the largest degree terms and things like that, but that's not the case, right? So let's do an example to figure out what this is all about. So we have 3x squared y plus 6x squared y squared plus 3xy. Okay, so the first step, and these are just kind of intermediate steps. After a while, you'll be able to sort of see, exactly what needs to happen in each case, but we're going to write it out sort of longhand this first time. So if we write this guy out in its prime factorization form, we're going to have 3x, y, it's going to be plus a 2 times a 3, right? Because 2 times 3 equals 6 times x times y plus 3xy. Okay, so now we have all of our terms in prime factorizations. Now we need to look through each and every one of these terms and determine what is the greatest common factor of each sort of type, right? And so what's the greatest common factor of coefficients is what we'll figure out. What's the greatest common factor of x's, and what's the greatest common factor of y? And all those put together is the greatest common factor of the polynomial. Okay, so let me just erase this stuff real quick. Whoops, that should be a 3 there. Okay, so let's go through each term, right? And let's see what's contained in each term. So this first term, we've got a 3 contained in it, right? So let's check the other terms to see if there are 3 contained in those as well. And there are. So we know that 3 is going to be part of our greatest common factor, right? And so let's just take it one sort of step at a time through this first term, and we'll check the remaining terms to see if they have common factors, right? So this first term has 1, 2 x's. The second term also has 1, 2 x's. The third term, however, only has a single x, right? And so we are factoring out the greatest common factor, right? So it has to be common. 2 factors of x is not common, but 1 is, right? Each term has at least 1 factor of x, and so we're allowed to pull one of those factors out of each term. Whoops, that shouldn't be a 3, that should be an x. Okay, so the next term is an x. Right, and we know that the x is only first degree because the rule goes as such, right? They say if there is a common variable in each term, the number of those that you're going to factor out is the least degree of those terms, right? We have a degree 1 over here on the x, and so that's exactly what we factored out, an x of degree 1. Okay, so now we're going to do the same thing with the y's, right? We have 1y. We have 2 y's, and we have 1 y. Right? We might be tempted to factor out 2 y's, but we can't do that because this term only has 1, and this term only has 1. Right? And so kind of by the other way that we do this, we'll say, okay, all 3 terms have y's, so we're going to factor out the y with the lowest degree. This has degree 1. This also has degree 1. This guy in the middle has degree 2, so we're going to factor out a degree 1. Okay, now all we need to do is go through and we just write down what we have left inside the brackets. So, on this first one, notice that we pulled out a 3x and a y. So that leaves us with an x as a factor. Right? On this second one, we pulled out a 3, an x, and a y. What does that leave us with? Well, that leaves us with 2xy. On this last one, we pulled out all the terms, right? 3x and y. So that means this last one is just a 1. It's really important to remember this 1 here, right? Because when you multiply this guy back out to check your work, if you don't have this 1 here, you're going to get the wrong answer. Okay, so that was it. That was kind of like our longhand version, right? We break it down into its prime factors and we see which factors it has in common. And then we take the number of factors of the least degree term, right? The least number of x's in any term, that's how many x's we take out. There's only one x in this term, so we could only take one x out of all terms, right? That's what it means by the greatest common factor. Okay, let's try one more example. This one's a little bit uglier. And, sometimes the hardest part about these problems is just writing down all this mess. So we have 36x y squared z cubed plus 36x cubed y squared z plus 9x squared y z. Next step is going to be to break down everything into its prime factorization. I'm going to do things a little bit differently this time in that I'm just going to break down the coefficients into their prime factorizations. I'm going to leave the exponents as is because that'll help to inform us kind of what we're doing here with the degrees. So, okay. So in our next line, we're going to break each of these down into their prime factorizations. Well, the prime factorization of 36 is 2 times 2 times 3 times 3, because 4 times 9 is 36. So we have that, and then we just write our powers as they are. Z cubed. Right, this one's the same thing. 2 times 2 times 3 times 3 times x cubed times y squared times z. This last one, 9, the prime factorization of that is just 3 times 3, x squared y z. Okay, so now let's go ahead and go through this term by term to determine what we can factor out. So let's deal with the coefficients first. What kind of coefficient factors do we have? Well, in this first term, we have 2 2's and 2 3's. The second term, we have the same. But the third term, there are no 2's, which means we can't factor the 2's out, right? Because they're not present in each and every term, so we can't factor them out. It's impossible. So the 2's stay. But each term does have 2 3's. And since there are 2 3's in each term, and not 1 in one of them or something like that, we're allowed to factor those 2 3's out. So 2 3's, well, that's equal to a 9. So next let's go through the variables one at a time and determine how many of them we can factor out. Right? So this first term, it has an x. This x is degree 1. So, this tells us right away that if there are common x's in all these terms, the most we can factor out is 1, right? Because this first term just limited us on that. How many are contained in this? Well, there's actually 3 in this one, and there's 2 in the final term, right? And so this still tells us, it says, well, x is present in every term, but we can only factor out the least degree, and that's 1. So we factor out an x. Let's move on to the y's. So we have a y squared in the first term, a y squared in the second term. See this little square here and here, right? But we only have a y to the 1 in the third term. So y is present in every term, but it's only a degree 1 in one of those terms, so that's all we can factor out. Okay, so now let's tackle the z's. Right, the z's, you can see right now they're the same exact situation, right? We have z's present in all terms, but 2 of the terms only have a z to the first degree, so that's all we can factor out, z. Okay, so now let's go through and see what we have left. So we never factored out the 2's, so we have a 4 out front here. We did factor out the 3's, so those are gone. We factored out 1x, right? We factored out 1y, and so this is going to change to a 1. We factored out 1z, so this is going to change to a 2. And then we move on to the next term. Still have our 2's left, the 3's are gone, so we have a 4 here. We factored out 1 of these 3 x's, right? So this is going to turn into a 2. We factored out 1 of the 2 y's, so this is going to turn into a 1. And then we factored out 1 of the z's. And so that sort of just goes away. It basically turns into a 1, which we don't need to write. Okay, we factored out both our 3's in this last term. We only factored out one of these x's, so we have one left. We factored out a y and a z. We only have one y and z in the last term, so those turn into 1's. Okay, so that's it. That was our last term. Draw our bracket in and we're done. And we can test this guy out by distributing this into each and every term. So what did we do there? Well, all we did was break this 36 down into its prime factors to see what the common factor was, right? And it turns out it was 9. Then we went through each variable one at a time, and we said, is the variable contained in every term? If it is, what's the least degree that variable appears in the terms, right? And so if there was only a single degree x in one of the terms, that's all you can factor out, right? It doesn't matter if there's 5,000 x's in one of the other terms. You can't factor out more than 1, right? And so if we have, if this is for an illustration, if we have x minus, let's say, x to the 3,645, right? We can factor out an x, but we can only factor out 1 because that's the least degree x. So you factor the x out and you get 1 minus x to the 3,644. Right, and so that's kind of the toughest part about this, is just realizing that, you know, even if you have a large number of x factors over here, if their counterpart is a low factor of x, then that's all you can factor out. It can be frustrating sometimes, but it's okay. All right, so that is the video on greatest common factors. I will be moving on to release more videos later today. I hope this helped.